Today we want to practice actually being able to simplify and find particular values and limits, right? So I'll just quickly going over the limit rules. Remember, you can pull the K on the outside. You can split it up if it's a product. You can split it up if it is multiplication. You can also split it up if it's a addition and division, right? And please remember that you can also do it if you have it in the form N. Okay, so just remember these rules. We'll go back to these rules when we start to simplify limits, right? And the two techniques for simplifying limits are number one, factorization. Number two, dividing by the highest power. Remember to always check if factorization will work first. If factorization doesn't work, then you go to divide by the highest power. And Hôpital is a technique to check the answer, right? So what is Hôpital? Hôpital is not actual proof. What Hôpital is, it just allows you to check the answer. Okay? So here what you're doing Hôpital. You differentiate your numerator, differentiate the denominator, and you put in the answer. Right? If it's still undefined, you try it again. Let me show you what I'm talking about. Differential of 3x's, 3. Differential of x squared minus 4's, plug in infinity. 3 over infinity. So the answer is, that's okay. But Hôpital is not a valid solution at unit 1 level. So you have to do method 1 and method 2 to get the marks. But you can use it just to make sure you get the right answer. Before we go on to the other rules, let's see if we can work out these 3 here. Always check factorization first, right? If after you do factorization and divide by the highest power and still get infinity, it means the answer is infinity, right? Let's check out the first one. So would you be able to factorize the first one? No. You wouldn't be able to factorize. So we have to divide by the highest power. So we're going to get 3x squared on x squared plus 1 on x squared over 2x on x squared minus 1 on x squared. So we're going to get the limit that x approaches infinity. You always have to keep writing the limit until you substitute, right? So you'll get 3 plus 1 on x squared, 2 on x minus 1 on x squared. Then you plug in infinity. So it's 3 plus 1 on infinity, 2 on infinity minus 1 on infinity. So I am getting 3 plus 0 over 0. Infinity. Let's check Hôpital. Differentiate 3x squared and we're going to get 6x. Differentiate 2x and we will get 2. And when you plug in infinity, you're still getting infinity on 2, which is infinity. Number 2 is what? What you'll use for this one again? Factorization, right? So when you factorize x squared minus 4, sorry. You'll get x minus 2 by x plus 2. And when you factorize the denominator, you'll get 2x by x minus 2. And what will happen? So you'll end up with the limit as x approaches 12. What's the next step? Substitute. Plug in 2 and you'll get 2 plus 2 over 4, which is limit as x approaches 3 of f of x. I'm just going to split it up, right? There's a plus sign here, so I'm going to split it up. Plus the limit as x approaches 3 of 2x is equal to 8. What you do with this 4, Daria? Just put it on the outside. Okay. Alright, so it's 4 by the limit. So the trick is really to figure out what the limit is. What's this value here, Adrian? What is the limit of 2x as x approaches 3? 2 by 3 is 6, right? So what we really have here is the limit as x approaches 3 of f of x plus 6 is equal to 8. So Well, what does that say about the limit earlier? The limit is how much? All right, so the limit of f of x as x approaches 3 is 2. Now you wrap it up there. 4 by 2, that's 8. Right, so those were the first set of rules. Now we have tricks. So do me a favor, write down these trick rules here. Right, so let's try this one here. Right, so if you look at the rule, you might see that marker. Right, if you look at the rule, right, the rule says that sine x on x as x approaches 0, that limit is 1. Right. So this question would have been really, really easy if I had 3 here. That's okay? Because I will have 3x. I will have 3x and 3x. So how do I bring that 3 in there? Well, to bring that 3 in there, I could multiply by 1. But to be more specific, instead of 1, I multiply by 3 on 3. So when I multiply that, I will end up with the limit as x approaches 0 of sine. So I'm multiplying 3 by this. So I'm putting the 3 on the outside. Remember, don't multiply 3 by this, that's wrong. It's 3 by this whole thing, and then 3 by x, which is 3x. So everything nice here so far, right? I'm going to take this 3 and bring it out here. So I'll end up with 3 by the limit as x approaches 0 of sine 3x over 3x. This whole thing is how much? This will be 1. All right? What's the answer for this one? If you had a guess, hopefully you did it already. Yeah, the answer might be 2/3. But these are the steps I want you to take in order to work it out. All right? Might be a little long, although we know the answer, but you have to do it properly. All right? All right, so watch this here. In order for this to work, it has to be sine 2x on 2x, sine 3x on 3x, correct? Yeah, for it to work, right? So how are we going to achieve that, Adrian? What we're going to do is we're going to use the limit, divide, we're going to split it up. So we're going to get the limit as x approaches 0 of sine 2x divided by the limit as x approaches 0 of sine 3x. Right? These are the proper steps to take, right? Next, what do I want? What do I want? I want to get 2x underneath here, right? Yeah. So I'm going to multiply by 2x over 2x. Is that okay? Would I change the answer? No. 2x on 2x is 1. What would I do here? Yes. Multiply by 3x on 3x. I write in all these steps, right? For you to see what's going on, right? So this will be the limit as x approaches 0 of sine 2x over 2x. Remember, it's limited this by this, right? So I put in multiply by 2x. You okay with that? Divided by, I'm doing the same thing here. The limit as x approaches 0 of sine 3x on 3x multiplied by 3x. Don't just cancel off things here, you cannot. Right? Don't just say that this is 1 and then left with 2x. Don't do that. That's wrong. What are you doing? What you're doing is this. The limit as x approaches 0 of sine 2x on 2x multiplied by, I'm putting a dot for now, right? Limit, so it's this by this by this. As x approaches 0 of 2x. You okay with that? I'm going to do the same thing here. Limit as x approaches 0 of sine 3x on 3x multiplied by the limit of 3x as x approaches 0. Right? This value here is how much? This value here is how much? That's okay? If you were to plug in 0 here, what you'll get? You'll get 0, but you don't want that, right? Here's what you're going to do now. Put it 2 on the outside. So you'll get 2 by the limit as x approaches 0 of x all over 3 by the limit as x approaches 0. This will cancel and you will get 2. The only other technique that I like is watch. If you were to bring it back underneath and you cancel off the x's and then work it out, I'll take that. All right? But you can't magically just take this off and leave it as 2x because this is a product. The limit of this and this. But if you bring this underneath here and you let the x's cancel off, right? And you left it a constant, that will do. Right? You can just pull the constant on the outside after. So that's the way you handle questions like because remember, you want to get it in a particular form. So you could multiply anything by 1. Will you change the question? No. And that multiplying by 1 allows you to end up with this. Because remember, you had to reach here to use the rule. You have to get it, otherwise you can't use the rule. Yeah. And then you divide this by this. Right? The good thing is we know all the answers, right? Right? Let's work it out quick. So you all can identify what I'm doing already, right? So a limit as x approaches 0 will be sine 4x all on 4x multiplied by 4x divided by the limit as x approaches 0 of sine 5x all over 5x by 5x. Right? And just break it up here and we're done. Right? The limit as x approaches 0 of sine 4x on 4x multiplied by the limit. You can put the 4 in front one time as x approaches 0 of x all over the limit as x approaches 0 of right, this will cancel off and this is 1. So you'll end up with 4 and 5. All right. I try this one here. This is 2012. The limit as x approaches 0 of 2x cubed plus 4x all over. Right? Do you think there? All right, so how are we doing this here? First thing we can do, we want to get 2x here. So we can multiply by 2x, divide by 2x. So you'll end up with the limit as x approaches 0 of 2x cubed plus 4x. I don't want to bring it in here yet, right? Right, so you can probably factorize if you want, and then you will see what will happen there. But in case you didn't see it, I'm leaving it like this. Divided by the limit as x approaches 0 of sine 2x on 2x multiply by the limit as x approaches 0 of 2x. What will happen here? That's 1, right? So you're going to end up now with this divided by this. Go plug in 0, right? So therefore, if I have 2x underneath and I have this on top, I might be able to do some factorization. No? You sure? 2x by x squared is 2x cubed. 2x by 2 is 4. Divided by divided by the limit as x approaches of 2x. Right? What will happen here now? This will be the limit as x approaches 0 of 2x multiplied by the limit as x approaches 0 of x squared plus 2 all over the limit as x approaches 0 of 2x. This will cancel, and then I can plug in 0. So I'll get 0 squared plus 2. Let's combine what we did today, what we did last week. Let's try this here. Right, so it's a mixture of what we did last week to show something continuous, right? So the question said, if it continuous, find the value of a. Right, so remember, if something is continuous, what are the two rules again? The limit, right? And it must be equal to, right? So the limit of f of x as x approaches 0 should be equal to f of 0. So in this question, what is f of 0? Very good. X equal to 4 is defined when x equal to 0, and the answer is 4. So basically, you're trying to figure this out. What is a? The only way you could use the rule is if what? If you have ax here and also what down there. So multiply by a alone? A on a. So multiply by a on a. So what you'll get? This a comes out here, and you'll get a by the limit at x approaches 0 of sine ax over ax is equal to 4. This here is how much? 1. So a by 1 is 4. So let's go again. Determine whether or not the limits at x equal to 1 exists. Right, so remember, for a limit to exist, right, you have to approach from the right. It has to be equal to the same as the approach from the left. Okay, so if you approach from the right, you're using here, right? So the limit at x approaches 1 from the right, we're using this function here. Right, so you just put in 4 by 1 and you get in 4. Now, as it approaches from the left, the limit as x approaches 1 from the left, we have to use x to the 4th minus 1 over x minus 1. So we had to check and see if we could factorize, or check and see if we could divide by the highest form. Look at that difference of 2 squares. So you could factorize that. Oh. X to the 4th minus 1 to the 4th is the same as x squared squared minus 1 squared squared. So you'll end up with x squared minus 1 by x squared plus 1, right? So you still have to remember your form 5 expansions. Huh? So you'll get x minus 1, x plus 1 all over. Now you're going to cancel it off. Okay? And now we can plug in 1. So if I substitute x as 1, I put the answer to the left here, right? I'll get 1 plus 1 by 1 squared plus 1, which is 4. So does the limit exist? Limit exists. So the next part is if it's continuous, and the answer is no, because f of 1 is 2.